In this lesson, we're going to learn how to construct chemical formulas for ionic compounds based on the known charges of those ions. What we talked about with molecular compounds and are going to talk about with ionic compounds is all a bigger system called nomenclature. And this is a systematic method for naming compounds. In general, compounds are divided into organic and inorganic compounds. Organic compounds contain primarily carbon and hydrogen, but we'll see other atoms mixed in, and we won't really discuss those in this course. In this course, we'll focus more on inorganic compounds, specifically looking at ionic compounds, our metal plus our nonmetal, molecular compounds, two or more nonmetals, which we just talked about. And those are a lot easier to deal with because they give the number of each element in the name, and acids and bases. And we'll talk about some acids. Bases are really easy once we know ionic nomenclature. Depends on the type of acid we have. We'll look briefly at hydrates just so you're familiar with them, but we won't really do any naming with them. Before we start building compounds, we first have to look at the type of ions that we have. Remember that we have cations, which have a positive charge, anions, which have a negative charge. We also see that we have monatomic ions, so we have a single atom with a charge. And we're also going to see polyatomic, so many atom ions. And these are multiple atoms acting as a group. When we look at monatomic ions, what we see is that we can predict the charge of the main group elements based on where they are in the periodic table. For example, when we look at the first column, or group 1, we see that the elements in this column all form a +1 charge. Note that hydrogen again is an outlier. It can be +1 or -1. You'd have to have some additional information to know when it's going to be -1. We're focusing mainly on those metals from lithium on down. When I look at group 2, I see that these all form a +2 charge. We're going to skip over the transition elements and talk about those in a minute. When I get to column 13, I see that these elements tend to form a +3 charge. Aluminum is really the only one we see with any frequency in ionic compounds. Next, we're going to go over to column 18, and what we see is that these don't form ions. These are our noble gases. The electronic structure of these atoms is such that they are very stable the way they are, so they're not likely to give up or accept electrons. They're not likely to share electrons, so they just generally don't form ions. They tend not to form bonds at all. When I go to group 17, I see these have a -1 charge. Group 16 has a -2 charge, and group 15 has a -3 charge. Later on, we'll talk more about the electronic structure of the atoms, but ultimately, what these atoms are trying to do is to gain or lose enough electrons so that they have a similar electronic structure to one of the noble gases. Fluorine is going to gain an electron to look like neon. Oxygen is going to gain 2 electrons to have the same number of electrons as neon. Nitrogen is going to gain 3. On the other side, sodium will lose 1. Magnesium will lose 2 because there's a stability associated with having that number of electrons, and we'll learn more about the details of that later on. When we look at transition elements, things get a little murkier. What we see is that we cannot necessarily predict the charges on transition metals. And most of the transition metals will actually have multiple charges. So for example, titanium, Ti, can have a +2 or a +3 charge. Copper can have +1 or +2. And it's not as easy to predict those charges even based on the electronic structure. So we have to have some other information that tells us which ion of that metal we have. Which statement is true? All of these are talking about metals. And the first thing we can see is which ones are talking about cations, because metals form cations. Therefore, we know our answer is going to be A or C. And we have to look at what's happening. Are we losing electrons or gaining electrons? Remember, cations form from the loss of electrons. So A is our correct answer. Gaining electrons would form an anion, and nonmetals tend to form anions. Metals form cations. When we look at polyatomic ions, what we see is that these groups of atoms act as a group with a charge. These polyatomic ions always behave as a group with an overall charge on the group, not a charge on the individual atom. Here's a sampling of the polyatomic ions. There's a more extensive list which you're responsible for knowing on that Concepts to Memorize page that you can find through Canvas. Notice we only have one polyatomic cation, which is NH4+. The other ones are all anions. There are various ways to learn these. Some people use flashcards. There are songs that you might find online that help you learn them. The more practice you would do with them, the easier it'll be to learn them. Notice that when you look at ions that have similar names, such as chlorate and chlorite, or sulfate and sulfite, you notice that the charge is the same on both pairs of those, and the difference is with the number of oxygens. So when I go from chlorate to chlorite, chlorite has one less oxygen than chlorate. Same thing with sulfate and sulfite, which we had a little typo there. So sulfite has one less oxygen than sulfate. And that's true for all of those oxyanions. And we call them oxyanions because they're anions that contain oxygen and some other element. What is the charge on phosphorus with the symbol P in an ionic compound? First, we have to locate phosphorus on the periodic table, which is over here on the nonmetal side. Then we see where it's located on the periodic table, remembering that the last column does not form an ion. Those are the noble gases. And then we see we get -1 in group 17, -2 in group 16, and -3 in group 15. It is 3 away from argon, so it's trying to gain 3 electrons to have the same number of electrons as argon. So F is the correct answer. Now that we've learned a little bit about ions, now we need to see what happens when these ions come together. Because we're still transferring electrons between the ions, but they have to be paired up because we have to overall have that neutral charge. We can't just have a charged particle. We have to have something that has the opposite charge to balance that out. Let's look at what happens with NaCl. Na is a metal. It's one away from looking like the noble gas neon, so it's going to lose 1 electron and form an Na plus ion. Chlorine is going to gain 1 electron, so it has the same number of electrons as neon, and it's going to form an anion with a -1 charge. So we take 1 sodium ion and 1 chloride ion, and together they form NaCl, which is also known as table salt. And when we look at the charges, we see we have 1 atom or 1 ion with a +1 charge, 1 ion with a -1 charge, and when we add those together, we get 0. And that's what we need to see for all of our ionic compounds. The sum of the charges must be equal to 0 because the number of electrons lost to form the cation must be equal to the number of electrons gained by the anions. In sodium chloride, we have a 1-to-1 ratio because we lost an electron and gained an electron. So the number lost equals the number gained.